Now in this video, we will recap what is chromatography and introduce a new way of measurement in chromatography. You should recall that in chromatography, you drop a small amount of the substance on the filter paper and you dip the paper in a solvent, for example water, and as the solvent moves, the different components of the substance will move. And because they move at different rates, different components will separate as they move up the filter paper. Those that are more soluble will move further along with the solvent, and those that are less soluble will move less. Now, pictorially, this is what it looks like. All the substances will be placed at the origin line, so that's here. And we call that the start line or origin. And those that are more soluble will move further, and those that are less soluble are the ones closer to the origin. Now, you may wonder why this may be so. Now, let us take the example of travelators. I love seeing travelators because it probably means I'm at Changi Airport and I'm going to fly off somewhere and I get to shop duty free. Now, take that we all need to get to a certain boarding gate from where we enter. So, for example, here is the boarding gate, A, for example. And we all have this certain way there. And there may be like two travelators. Okay, so travelator 1 and travelator 2. Now, for those of you who like shopping, you probably won't take a travelator for long. You'll probably take one of them, maybe travelator 2, and then you like hop off here to go to a shop. But those of you who don't like shopping or if you're rushing for your flight, you'll probably be moving much faster to your boarding gate. Now, this is the same for substances. Those that are more soluble are like those on the travelator, moving very fast to the end. And those that are less soluble don't like being on the travelator of the solvent and move very slowly. Now, this video summarizes what I just said.
A useful analogy to describe chromatography is to think of three groups of tourists arriving at an airport. In this case, we have red, blue, and green tourists. There happens to be 7 red, 9 blue, and 5 green tourists. As everyone proceeds through the security checkpoint, the three groups are clustered together. There has been no separation yet. Everyone then jumps on the moving walkway and heads towards the plane. Now this is where the fun begins. There are shops along the moving walkway, and as the tourists are allowed to get off and on the moving walkway to do a little shopping. The shops in this case happen to be duty-free clothes shops. The thing is that each of the tourists like clothes shopping to different degrees. The red tourists aren't all that fussed with the shops, but spend a little time browsing. The green tourists, on the other hand, love the shops and spend heaps of time in there. The blue tourists, well, they're somewhere in between the red and the green. Hopefully you can see the similarity here to chromatography. The moving walkway is the mobile phase, and the shops, well, they're the stationary phase. The time the tourists spend in the shops determines how long it takes them before they get onto the plane. The flip side of all this is that all the tourists, regardless of which colour they are, spend equal amounts of time on the moving walkway. You can use your imagination here to think, how could we change the order of the tourists entering the plane? Well, say, instead of clothes shops, we replace these with cafes. Now the red tourists, well, they love a coffee, so they now spend much more time in the cafes and come out last. You can see what effect changing the stationary phase can have.
Now we're going to have 2 quizzes now. So, to recap, and please do it in the question box. Now, there are certain precautions we need to take when setting up chromatography. First, we need to draw the start line with a pencil. Now, why not pen? Well, for example, a black pen isn't really black, right? We know that it's a mixture of colors. So you draw the line with a pen, it will also dissolve and move up in the solvent. So pencil doesn't dissolve in most solvents, so it's good to draw the start line with. Now, secondly, when we place the spots, we need small spots. Now, if the spots are too big, they will come into each other's lane. So imagine if my spot is like this big, it's like having two big oil tanks in the same road, they'll probably overlap at some point. So they are likely to crash into one another's lane and you can't see anything. It will just be an artistic masterpiece of colors. Now, the choice of solvent is also quite important. Like the quiz earlier, if you choose the wrong solvent, the substance might not move at all and it might stay at origin. Now, this does not mean it consists of one substance. It just means it is not soluble in a solvent at all. So usually you do a trial with various solvents. And when you place the filter paper in the solvent, do make sure that the origin is above the solvent. So here is the origin and your solvent is here. It should be above the solvent. Or all your spots will all dissolve before moving off. Lastly, the setup is usually covered with a lid. Now this is to prevent the solvent from evaporating or you have no more solvent left. Now all these 5 precautions are usually tested, so do take it down in your notes. It is also covered in some of your critical questions. Now, after we have set up the chromatography and after all the spots have moved, the paper you end up with is called a chromatogram. So back to why we use chromatography. We need to know whether a substance is pure. So if the spot actually moves and it only has one spot like here, we know that the substance is pure. Like I was saying, if there's no spot at all and there's only a spot at the origin, it means that the substance is insoluble in a solvent and you should choose a different solvent. Now the spot has moved from the origin and you see more than one spot, like in this case, then the substance is a mixture. Now we're going to look at something we have not learned before in lower sec, and this value is called the RF value. It is the ratio between the distance traveled by the substance, that means spot, and the distance traveled by the solvent. Now you should see this formula on page 1 and point 3 of your notes. So this is the distance traveled by the substance, and this one in green is the distance traveled by the solvent. Now, the distance traveled by the substance and the solvent depends on how long you leave the paper in the solvent for. So if you leave it in for a longer period of time, of course it will travel further, like you see in the pictures here. However, the good thing is no matter how long you leave it for, the RF value for a particular component or substance remains the same no matter what distance the substance travels. So it means it doesn't matter if you leave it for this amount of time or this amount of time. If you calculate the RF value for both of these should be exactly the same. Now, how do you calculate the RF value? So take for example, you see the distance from the middle of the spot. So if your spot is really big like this, you take the middle of the spot and you measure the distance all the way down to the origin, and this in this case is 3 cm, and distance from the solvent. Now this one you have to mark out after you have taken it out of the solvent, like a pencil. If not, all the solvent will evaporate and you can't see where the solvent has stopped. In this case it is 4.5 cm, so you take 3 divided by 4.5, your RF value is 0.67. Now if you leave it in for a longer period of time, and if you measure it, you should see that the RF value is exactly the same. But the RF value does change if you change the conditions. So for example, You change the solvent or you change the temperature. So in this case, if I put the same substance in water and in alcohol, in this case, the substance likes alcohol a lot more, not unlike us, and it travels a lot further in this solvent alcohol. And the RF value for these two will not be the same. So do take this down as this is quite important to remember. Now, you may wonder, what if my substance is colorless? Now, most things are colorless. If you dissolve some of your medicines in water, you will realize that most of them are colorless. So for such things, we need to spray what we call a locating agent. It's a bit like spraying a dye. So for amino acids, the locating agent is called ninhydrin. So this is the only locating agent you need to know for the O levels, and this reacts with amino acids to produce a purple color. Now, a quiz to recap what we have learned. So, which dyes are pure? And what can you say about dye B and C? Now, another quiz. So, let's say we have an athlete that is doping. So, you know that many athletes are found to be doping, especially before major competition or Olympics. So, let's say we want to find out whether this athlete has been doping, and we take a sample of his blood at X and we put it on a chromatogram together at 4 of the band. So, these are the results. So, can you tell if this athlete is doping? Now, you can see that sample X does not contain banned drugs A, B, and C because all of A, B, and C, all the spots do not match up to where the spots of X are. Even for B, only 1 or 2 of the spots match, so that's not counted. Okay, but we see that, yes, there is an exact match between the spots, the 2 spots for C and 2 or 3 spots of X. So indeed, the athlete's blood does contain the banned drug C and he was doping. Now, another example of chromatography is when we want to find out if someone has been forging a document. So maybe we check the ink used, whether the ink used is different. So let's watch this video in CSI to find out.
What is it?
Telephone poles. Tom Harper's work order for Bianca's DSL line was dated December 18th. December 18th fell on a Sunday. How many workers you know work on a Sunday?
Is this the original document?
Yeah.
I'm on it.
Always a utility guy.
On the work order, which means the date on the work order was compromised. Tom Harper made a service call to Bianca's house, not in December, but 10 months earlier in February.
Why would the guy lie?
It appears that he was a lot more to her than just a phone guy. Our bachelorette was a very busy girl. Phone call.
Now, how did the person know that the inks were different? So you have realized that if you look very closely, the dyes on each ink had a different pattern, so it means that They didn't contain the same colors, so indeed there was a different ink used on the paper. Now, do complete the following questions before class. And that's the end of this video.